So DPP 3.3 is about geometrical isomerism. There are a lot of questions which are given, so it actually will be a good practice once you complete this DPP related with geometrical isomerism. Ninth one, which of the following statement is true regarding cis and trans butene? So this one is cis and this is the trans. Options are both have similar van der Waals attractions. Now tell me, van der Waals attractions is dependent on what factor of a compound or a molecule? Molecule having weaker or stronger van der Waals attraction is dependent on what?
Molar mass.
Molar mass. We know that in organic chemistry, down the group, as the molar mass increases, the van der Waals attractions were becoming stronger. So now, if we have butene ka cis and trans, will there be a difference in the van der Waals attractions?
No.
No, they both will have similar van der Waals attraction. So A option is correct. अब ऑप्शन यहाँ पर ऐसा भी है, both have similar dipole attractions. The dipole attractions are dependent on.
Molar mass.
No, 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 no. Didn't we talk about the dipole vectors in case of cis versus trans?
So, but in noble gases, you had said that dipole is proportional to molar mass.
Yeah, in that case, we don't have the geometrical isomers in that case, na? यहाँ पर तो arrangement अलग है ना? The stereo part is also a factor over here. When we talk about the inert gases, there is no stereo part which is included over there, right?
Yes, sir.
अब cis and trans में तो I had showed you the dipole vectors, right? This is sp3 and this is sp2. So the it is actually dependent on the difference in electronegativity and the bond length. Whenever I talk about dipole moment, it is something which is related with the charge and distance measured in a unit called
Debye.
device, coulomb into meter, right? So इस case में the dipole is in the same direction, so the resultant will be added up, and trans के case में they are in the opposite direction, so they will get cancelled off. So basically the mu or the dipole moment of the trans butane is zero. Here there will be non-zero dipole moment. Only the cis one is polar. Now, इसी के basis पे we had discussed lot of properties. Since the cis butane is polar, it is soluble in water, it has a high boiling point, and because of less symmetry, it has a low melting point. ये सारी properties were dependent on dipole moment, right? Are you getting it?
Yes,
This
sir.
this one is polar. Polar molecules are those which will have a high boiling point, also the high dipole moment, and less symmetry. That is why it has a low melting point. These things were concluded with the dipole moment and the symmetry concept. So the answer is option B. Both isomers have similar van der Waals attraction, which is dependent on molar mass, but only the cis has the dipole attraction because the trans has a zero dipole moment. Hence, the answer is D. 12th one, in which option all compounds can show geometrical isomerism? Is option A correct for this? All compounds show GI. First one is 1,2-dichloropropane. Will it show GI? Hello. 1,2-disubstituted cyclopropane. Does it show GI or not? We can have the chlorine lying on the same side and the chlorine atoms lying on the opposite side. Definitely यहाँ पर we have cis and trans possible. हेलो,
Yes, sir.
ठीक है, तो ये बताएगा. नेक्स्ट, दिस इज एन ऑक्साइन. Oximes has a tendency to show GI, but the condition was the,
different substituents.
the double bonded carbon should have different substituents. तो यहाँ पर तो दोनों methyl group है. This won't be showing the GI. और last वाला जो है वो GI बताएगा because of the butene structure. ठीक है, तो all compounds की बात कर रहे हैं, तो A में सारे नहीं बता रहे हैं. B में the first one which is 1,1 chlorobromo cyclohexane. If two substituents are on the same carbon, does it show GI? एक ही कार्बन पे दोनों सब्स्टिट्यूएंट्स है, तो इज द जीआई पॉसिबल?
No.
नो, तो ये भी रूल्ड आउट है. ऑप्शन सी में we have the first option as butadiene. Can this show?
No,
टर्मिनल डबल बॉन्ड में कभी भी जीआई पॉसिबल नहीं होता है. Terminal double bond always have two hydrogen, meaning identical substituents. So the moment you see any terminal alkene, it will never ever show GI. That's the shortcut trick. And option D is the correct answer. Let's check it. We have the first one as CH3CH double bond NOH. Now this is acetaldehyde ka oxime, which is having different substituents on the double bonded carbon. So ये बताएगा. And the next one is a diene. Now diene में is this double bond a GI, a geometric center?
no,
No, because terminal है. ये वाला?
yes,
Yes. Substituents on the double bonded carbon are different on both the sides. Hence, this satisfies the condition for the GI. And here all the compounds can show. Actually, one more there compound is there. We have a cyclopropane with chlorobromo. जैसे 1,2 डाइसब्स्टिट्यूटेड कंपाउंड बता सकता है, वैसे if there are 3 substituents then there can be GI possible. Okay, इसमें 1 fluoro can be up, 2 can be down, 1 can be down and 2 can be up. वैसा सब अरेंजमेंट के बेसिस पे the GI will be possible. ठीक है, so this is just a condition based question where the GI is possible or not. Then we have 13th one. Which of the following will not show geometrical isomerism? Not show. So in the first option, we have a cyclobutane with a double bond. Then we have cyclobutane again with a methyl and ethyl on the right and chloro and H on the left. Now, this particular compound you can visualize similar to a cumulene having 3 double bonds with Cl and H, CH3 and C2H5. And whatever concept I had discussed in cumulene applies to the compound having cyclic double and cyclic combination or 3 cyclic combination or 1 cyclic 2 double bond. Any combination, it's similar to cumulene. So what was the conclusion for cumulines? Cumulines with odd number of double bonds show odd shows. Are you all there? Hello? Hello?
GI,
बोलो फिर. Cumulines with simple सा summary है. Cumulines with odd number of double bonds will show GI and even number of double bonds show OI.
OI.
Here the odd number of double bonds show GI because of plenarity and यहाँ पर plenarity is lost and shows OI. That is a simple one-liner conclusion. So now this is similar to a cumulene with 3, meaning odd number of double bonds, meaning it will show GI. Correct? And एक और condition था that substituents on the terminal carbon atom have to be different. अगर ये क्यूमुलिन में क्लोरो होता या 2 मिथाइल होता, then the GI won't have become possible. ए में GI होगा, आपसे पूछा है not show GI. अब बी ऑप्शन देख लेते हैं. बी ऑप्शन once again is a cumulene with क्या देख रहा है? 2 double
Even
bonds.
double.
तो इवन है मतलब ये ओ आई बताएगा, जी आई नहीं बताएगा, आंसर बी है. अब सी देखोगे तो इट्स अ क्यूमुलिन विथ ऑड, एंड डी देखोगे तो वो भी क्यूमुलिन जैसा ही विजुअलाइज कर सकते हो विद द ऑड नंबर ऑफ डबल बॉन्ड्स शोइंग जी आई. इज दिस पॉइंट क्लियर?
Yes, sir.
So there is one addition to the concept of the cumulines, that instead of the double bonds, you have the cyclic ring which has the same du as the double bond, have the same funda to be applied. It is similar to the cumulene. If there are odd number of rings, then it will show GI. Even number of rings, it will show OI. Fine. 14th. Which of the following molecule have 2R and 3Z configuration? 2R and 3Z. अब सबसे पहले, just by looking at the structures, you can rule out few options. Can you tell me which options are ruled out over here? 2R and 3Z. R is something which we have to identify by converting the wedge dash into fissure. तो R S को तो हम डायरेक्ट नहीं बता सकते, बट Z के लिए Jusaman configuration मतलब the two lower priority groups should be on the same side, or the two higher priority groups should be on the same side. So with that concept, can you tell me which options can be ruled out?
A and B.
A and B. Because with the double bonded carbon, there is a methyl and a H over here, and यहाँ पर H है, and we have carbon, methyl group, OH, and the H. This is the structure, right? अब यहाँ देखोगे, the two H are lying on the opposite side. So obviously they are the lower priority groups on the opposite side. Opposite side मतलब enemies, enemies मतलब E configuration. तो ए और बी दोनों में ई कॉन्फ़िगरेशन है, तो ये तो रूल्ड आउट है. अब चलते हैं हम अपने सी ऑप्शन पे, वेयर द एच इज अबव एंड सी एच थ्री इज बिलो. तो डेफिनेटली ये जेड तो हो गया. ठीक है, अब इसको हमें आइडेंटिफाई करना है. नाउ फॉर दिस आई विल बी कन्वर्टिंग इनटू द फिशर प्रोजेक्शन. व्हाट वाज द सिंपल ट्रिक गिवन कन्वर्ट टू फिशर?
If the angle is on the right, then solid wedge comes on the right.
Perfect. An angle is to be seen between the
Two bonds in the plane.
two bonds in the plane. So here we see the angle, and the angle is on the right. So the solid wedge comes on the right. H will go to the left. The methyl will be at the bottom, and the whole group with a double bond, which is CH, double bond CH, and CH3 will go on the top. Is this understood? Everyone? Look at the angle between the two bonds in the plane, and if it is in the right direction, on the right direction, then the solid wedge comes to the right. And that's the only placement which becomes important. Because once we have OH on the right, you understand H will be on the left. ऊपर वाला ऊपर जाएगा, नीचे वाला नीचे आएगा. This is ऊपर वाला valency, this is नीचे वाला valency, which is flattened onto the vertical line. That's the concept of converting the wedge dash into the Fisher projection. Got it? Bolo.
Yes, sir.
Okay, now it's just a matter of understanding the priorities. So OH gets the first, the double bonded carbon gets second, the methyl with 3H का set will be third, and this will be four. 1 2 3 घूम रहा है, 1 2 3 घूम रहा है.
S but होगा R.
घूम रहा है एंटी क्लॉकवाइज लेकिन होगा R. That's it. So this is the R configuration, and this double bonded have the Z. This is the correct combination of 2R and 3Z. Answer will be option C. And in the option D, you see this solid wedge and the dashed wedge ka valences are being inverted. So instead of R, now I will get the S over there, which will be an incorrect option. Understood? This is, this is a very simple way of converting the wedge dash into the Fisher projection. Then we have 15th one. The geometrical isomerism is shown by. First of all, कौन सा option rule out कर सकते हो?
A and B.
A and B because they are the terminal double bonds. Just by looking double bond CH2, you can understand वहाँ पर तो GI possible नहीं होगा. Let's look at option C, which is a cyclohexane, a double bond CH, Cl, and a methyl. Here the GI will be possible or not?
No,
No. Why?
because the substituent on either side of the carbon is same.
Correct. So here if you see the carbon, symmetry देखने के लिए मैंने क्या बोला था? Just travel from this carbon on the left and on the right side, and if you have all the substituents or all the carbons similar, then there is a symmetry. So here the next is CH2, यहाँ पर भी CH2, then CH2, then CH2, and then we have a CH with a methyl common. Meaning यहाँ पर symmetry है, यानी this double bonded carbon doesn't have different substituent. Option D में क्या किया है? They have shifted this methyl over here. Now on this side of the double bonded carbon, I have CH2, 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 CH with a methyl. So traveling on either side, I am not getting the similar carbon atoms. That is why there is no symmetry. I can say a double bonded carbon is having the different substituent. Understood?
Yes, sir.
That's why the answer is option D. Then look at the 19th one. The total number of geometrical isomers possible in the following compound is. Let's see the compound. It's pH with CH double bond CH. Then there is a cyclohexene, and we have CH double bond CH and CH3. So geometrical isomers पूछा है, तो we will first identify the geometric centers. Let's travel from the left side and tell me, will there be a geometric center over here? From left.
Yes.
This is a geometrical center because the double bonded carbon is having different substituents. So ये एक geometric center हुआ. Next is the double bond of cyclic ring. Cis and trans possible. What was the statement related to cycloalkene or GI?
At least 8 carbons.
Cycloocta, sorry, cyclooctene or onwards can show the cis and trans. So ये वाला double bond तो geometric center नहीं होगा. Moving to the right, is this a geometrical center?
Yes.
Yes. Anything else? If the ring is having the substituents on the 1 and 4 carbon atom, Will this be a geometric center? It's like cyclic ring having the substituent on the first and fourth, AB and AB type with a double bond over here. Yes. Will this be a geometric center?
Yes.
This is also 1 4 है ना? 1 4 में भी geometric isomerism will be possible. So overall there are 1, 2 and 3 geometric centers, and there is no symmetry in the compound. So the number of stereoisomers over here will be 2 raised to the number of stereo centers, which is equal to 2 raised to 3, and that's equal to 8. There are 8 stereoisomers possible for this compound, which are all geometric isomers. Understood? Next, 20th. Which of the following statement is not true about the following compound? There is a cyclic ring with a double bond here, and there is a ketonic group. In the next structure, the double bond O and internal double bond is at this position. And third, may I have double bond O and double bond here. Okay, so which of the following statement is not true? Option A, 1 and 3 are identical. 1 and 3 are identical. True or false?
True.
They are in conjugation in both the cases. But in the first one, the double bond is not at this two carbon atoms. In the third one, they are between this two carbon atoms. So does it make a difference in the structure? Just observe the double bond placement in the first one and in the third one. Does this placement of the double bond make the structure different?
No.
It does. It does make a difference. Because cyclic ring mein, the way in which we are showing the cyclic ring, it doesn't exist in the same form. It exists in a proper conformation. So based on the conformation, the double bond ka placement will have a difference in their structure also. These two are not identical structures. See, if I just number the carbons here as starting from this 1 2 3 4, तो यहाँ पे 1 2 के बीच में सिंगल है, यहाँ पे 1 2 के बीच में डबल है. ठीक है? I'm not talking about the nomenclature, just giving you the reference that this particular arrangement of the double bond in the cyclic ring, and this is of like 1 2 3 4 5 6 7 8 9 10, is cyclodecene का structure है. So it doesn't exist in this form as given. It exists in a proper conformation, not the chair conformation, but a different conformation. And उस conformation में axial, equatorial, and the arrangement of the internal double bond will have an impact on the structure. तो ध्यान रहे कि these two are not identical. और टू स्ट्रक्चर तो दोनों से डिफरेंट है ही बिकॉज दे आर नॉट हैविंग द पाई बॉन्ड्स इन कॉन्जुगेशन. तो सेकंड में तो क्लियर डिफरेंस है. वन में कॉन्जुगेशन में तो है बट द डबल बॉन्ड का प्लेसमेंट इज नॉट सेम. That is why they are different structures in the three dimension, in the conformational form to be specific. Clear? Understood.
Yes, sir.
Then 22nd, write all carbonyl compounds with molecular formula C3H6O and then on reaction with excess of NH2OH. How many total isomeric oximes are formed? So carbonyl compounds with this molecular formula will be which compounds?
Aldehyde ketone.
Aldehyde and ketone. In fact, it can represent aldehyde, ketone, unsaturated alcohol, unsaturated ether, cyclic alcohol, cyclic ether. But since they are talking only about carbonyl compound, meaning we have to talk about aldehyde and ketone. So which aldehyde is possible with this formula?
Propanol.
Propanol. Separate the functional group and represent the remaining carbon, that is 2, in the form of alkyl. This is propionaldehyde or propanol. And ketone के लिए 3-carbon ketone is the simplest of the ketone, which is famously
Acetone.
acetone. Now, if this is reacted with H2NOH, it will form an oxime, and the oxime would be CH double bond NOH and the methyl, sorry, ethyl, propionyl oxime, and this will have C double bond NOH with methyl over here. So, how many total oximes are getting formed? कितने oximes
3.
बनेंगे? 3. Because the first oxime is having the geometrical isomers also possible. There will be syn oxime and anti-oxime. But with the two methyl groups on the double bonded carbon, this is not going to show any GI, and that is why there will be syn and anti of the first one and acetoxime structure. So the correct answer is B. तो यहाँ पर structural isomerism भी आ गया, stereo isomerism भी आ गया. So combinedly, it was a question about both. Okay, 23rd is an incomplete question. There are two options which are missing, and the structure related to the question is also missing. 23 को cancel कर लो. Let's look at 24th. I have a cyclopropane with chloro up and down, and in the next structure, again, I have cyclopropane with the chloro up and down. What is the relation between these two? Multiple correct type है. Is the relation position, optical, geometrical, or diastereomer? 1,2-डाइक्लोरोप्रोपेन के दो स्ट्रक्चर्स दिए हैं. Can they be position?
No.
Both are 1,2. Optical? Are they the non-superimposable mirror images? कि भाई cyclopropane में I can have the Cl and H on the same side. I can have the Cl with H and H with Cl. The Cl is on the opposite side. This is the cis isomer and this is trans. Now, cis में if I take the mirror image, is it going to be different?
No.
No. But trans में if I take the mirror image, is it going to be different?
Yes.
Yes. मतलब कैन आई से दैट ट्रांस का डेक्स्ट्रो एंड ट्रांस का लेवो आइसोमर पॉसिबल होगा?
Yes, sir.
ठीक है, मतलब दिस इज द ट्रांस आइसोमर एंड दिस इफ आई से डेक्स्ट्रो, assuming it to be dextro, this will be levo and they are non superimposable mirror images, meaning the relation between them is they are optical isomers or enantiomers, right?
Yes.
Agreed or not? अगर ऐसे दो स्ट्रक्चर्स दिए जाते हैं where the two chlorines are on the same side and on the opposite side, they would have been, what would be the relation?
Geometric isomers.
And a pair of geometric isomers are also a pair of,
Diastereomers.
so in that case the option would have been C and D. ठीक है, तो पोजीशन तो निकल गया, ज्योमेट्रिकल नहीं है तो डाइस्टीरियोमर भी नहीं होगा, तो मल्टीपल करेक्ट जरूर है, बट देयर विल बी ओनली वन ऑप्शन पॉसिबल विच इज दे आर ऑप्टिकल आइसोमर्स. 25th, select the correct statement. A, there is a amine with nitrogen having H, methyl and ethyl is optically inactive, whereas we have an amine in the cyclic form, bicyclo compound with methyl, methyl, methyl and methyl. It's a lone pair here. Okay. Now, similar to the chiral carbon concept, in case of nitrogen, we can have a chiral nitrogen. Now, this concept is not in much detail, but there are two instances where the nitrogenous compound can also show optical activity. One is a case of ammonium ion, where if the ammonium ka nitrogen is bonded to four different groups similar to the carbon, let's say H, Me, Et, and propyl, then in this case, the ammonium ion, similar to the carbon, having a tetrahedral geometry, can show the optical isomerism. Can show optical isomerism. And a neutral nitrogenous compound in which the nitrogen ka lone pair is restricted or not allowed to have a free rotation possible. Free rotation या free movement which is restricted, then such type of nitrogenous compounds can also show optical activity. अब free rotation या movement का मतलब क्या? अगर मैं इस कंपाउंड को देखो, आई एम हैविंग नाइट्रोजन विथ H, methyl, ethyl and the lone pair. They are all different from each other. But this nitrogen का lone pair is in the pyramidal geometry. ठीक है, और ये pyramidal geometry में this have a movement which is possible. Because of that, this can't show the optical activity. लेकिन इसी lone pair को if we do the restriction on the nitrogen atom by attaching the bulkier substituents on the adjacent position, and if it is in the form of a cyclic form at the bridgehead carbon, जैसे अगर यहाँ C होता तो we would have called it bridge head, वैसे यहाँ पर नाइट्रोजन जो है वो ब्रिज हेड नाइट्रोजन है, ब्रिज हेड की पोजीशन पे है, तो नाइट्रोजन का यहाँ लोन पेयर जो है that is not having a free movement possible. One reason is it is at the bridge head position, and second it is surrounded by the bulkier groups on the adjacent position. Because of all these factors, it can have the optical activity possible. So nitrogenous compound may at the bridgehead, if you have nitrogen with the adjacent carbon having the bulkier substituents and ammonium ion with all the four valences different, these type of nitrogenous compounds similar to the chiral compounds can show optical activity. Samjha? So one more concept addition to the advanced. Nitrogenous compounds में भी optical activity possible है, Condition is the nitrogen should be at the bridgehead carbon with the lone pair surrounded by two bulkier substituents on the adjacent sides, and it can be possible in ammonium compounds with all the four valences different. ये concept तो बहुत simple है. This is exactly similar to the sp3 carbon having four different valencies. अमोनियम में भी नाइट्रोजन sp3 हो जाता है और चारों वैलेंसी अगर अलग है तो ये भी ऑप्टिकल आइसोमर्स बता सकता है. The first statement is absolutely correct and with an important concept added. Then B. B में there is a butane structure, N-butane, with these two carbons indicated alpha beta, and we have a propane compound with the two carbons indicated as alpha and beta. Question है about C alpha and C beta bonds. One has more energy barrier for rotation as compared to two. One has more barrier of rotation. Along this single bond, जब ये conformers शो करेगा तो इसमें रोटेट करने का बैरियर ज्यादा होगा एज कंपेयर टू टू. इज दिस करेक्ट? The barrier or the hindrance to rotation is dependent on what?
Weight of the substituents.
Weight of the substituents. So if I just write one more structure, I have ethane compound over here. तो सबसे easy rotation कहाँ पर होगा along the CC bond? 1 2 3 structures में.
Third one.
Third one, because there are all the hydrogen atoms on the carbon atom. Now, जैसे ही one of the hydrogen is replaced by methyl, there will be steric repulsions, तो rotation difficult हो जाएगा. और दो methyl group on either sides of the carbon will increase the steric repulsions. तो torsional strain आएगा यहाँ पर, van der Waals strains आएगा. तो second statement says that one has more energy barrier for rotation than two is absolutely correct. Then C, the boat form of cyclohexane is less stable than chair form due to torsional strain as well as fleck pole interaction. Boat form less stable hai than the chair form. Is that correct? The order of stability of the conformations of cyclohexane was chair followed by
Twist boat, boat, half.
twist boat, boat, and half chair. Where the twist boat was spiral and the boat was an
Eclipsed.
eclipsed conformation. And in this eclipsed conformation, because of the arrangement, these hydrogen atoms at the 1,4 position have the interactions which are called fleck pole interactions. The torsional strain to hai because of the eclipsed conformation, and this interaction because of the boat arrangement is called as fleck pole interaction. Matlab the boat form is less stable than chair due to torsional strain as well as fleck pole interaction is absolutely correct. Then we have the D1, interbutyl substituted cyclohexane. Most stable chair conformer has third butyl, CME3 matlab third butyl group on equatorial position. As per the rule, a bulkier substituent will always be preferred at.
So what is interbutyl?
Interbutyl matlab cyclohexane में one of the H is substituted by the third butyl group. Interbutyl matlab substituted on one of the hydrogen. In fact मुझे ऐसा लगता है वो interbutyl नहीं होगा, third butyl होगा. Because बाद में उन्होंने third butyl का substituent दिया. हाँ, this is not inter नहीं होगा वो, that is third butyl. Third butyl substituted cyclohexane, उसका most stable chair conformer हैज अ CMe3 ग्रुप ऑन इक्वेटोरियल पोजीशन, तो अगर कोई भी एक कार्बन पे CMe3 ले लेते हैं तो will it be preferred at the axial or on the equatorial position?
Equatorial.
बिकॉज axial पे क्या होता है, देर आर 1 2 3 axial repulsions. ठीक है, तो यहाँ पर H प्रेफर्ड होगा और यहाँ पर CMe3 प्रेफर्ड होगा, मतलब B is also a correct statement. So the correct options are A, B, C, D. All of them are correct. Got it.
Yes, sir.
28th one. Which of the following are correctly matched? So compound दिया है और number of geometric isomers दिए हैं. So let's start with the A1. CH3, CH double bond CH, CH double bond CH and a PH. So how many geometric center and how many isomers? Fast, fast, respond.
Two GI, four two geometric centers, so four
Two
GI.
geometric centers. And does the molecule have any symmetry? Symmetry है क्या? Obviously no. Methyl and phenyl है. So the molecule is unsymmetrical with two geometric centers, hence the number of isomers will be 2 square, which is equal to 4. तो एक correctly match कर रहा है. Then B, we have CH3 with a CH double bond CH 4 times and CH3. What can you comment on this? All the double bonds would be the geometric centers, but with the methyl group at the terminal position, the molecule has a
Symmetry.
symmetry. So if the molecule is symmetrical and the number of geometric centers are even, then number of geometric isomers are given by 2 raised to n minus 2 raised to n by 2 minus 1. That's 2 raised to 4 minus 2 raised to 2 minus 1, which is equal to 14 isomers. What they have given is 2, doesn't match. C में we have butadiene. Number of geometric isomers given are 10. What should be the actual answer?
0.
Obviously, it will not have any geometric isomer. यहाँ 0 होगा. And last one is H3C with a CH double bond CH 5 times and CH3. What can you comment on this structure? Quick, quick, quick. Similar to the B option. ये क्या है?
Symmetrical with odd number of stereo centers.
Symmetrical with odd number of stereo center and the middle one is odd है तो middle देखने का.
Geometric.
Geometric. So the formula was 2 raised to n minus इन दोनों में फर्क बहुत सिंपल था. दिस इज n by 2 minus 1,
N minus 1 by 2.
n minus 1 by 2. So 2 raised to 5 minus 2 raised to 4 by 2, which is equal to 32 minus 4, which is equal to 28. So only A matches. Correct answer is बी सी एंड डी मैच नहीं करता है. पीछे आंसर ए एंड डी दिया है, विच इज नॉट करेक्ट. इट विल बी ओनली ए. 31 is a very very good question. बहुत बढ़िया क्वेश्चन. Which of the following compound can exhibit free rotation? और इस तरह का एक क्वेश्चन मैंने नोट्स के एमसीक्यू में सॉल्व भी कराया है. There is a double bond surrounded with the rings on both sides, and the question is which can exhibit free rotation? What is the concept to do this? Solve this question. Right, we have already done. A simple hint, just एक चीज important है. फ्री रोटेशन के लिए it should have a single bond, and for the single bond I have to shift the pi electron. Now if I shift the pi electron, अब दोनों तरफ का रिंग सेम है. Either ways, if I shift, I will get plus on one carbon and minus on the other carbon, like this. अब यहाँ पे रोटेशन तभी पॉसिबल होगा if both the rings after the shifting of the pi electron and acquiring the polarity acquires stability. Acquires stability. So you have to now just check whether this ring is stable or not after the shifting and acquiring the polarity. Yes. Left hand side ring, is it stable?
Yes.
Yes. In fact, it is stable due to
Aromatic character.
aromatic character. Right hand side ring.
No.
No. This will be unstable, and in fact it will be unstable because of बोलो. It's simple. क्यों इतना
It's
difficult है?
non-aromatic.
It's not non-aromatic. Aromatic, anti-aromatic, non-aromatic. ये तो cyclic और planar concept हो जाएगा ना, because the lone pair is in conjugation. So it is cyclic, planar, but the number of delocalized electron will become how much?
4.
4 ना. तो cyclopropene के केस में the carbocation is aromatic, but the carbanion of that is anti-aromatic. ठीक है. तो इस केस में the second ring is not getting the stability. That is why this conversion of double into single bond and converting into the polarized form will not be possible. And if that is not possible, then the free rotation along the carbon to carbon single bond will also not be possible. अब आते हैं B वाले स्ट्रक्चर में. Now यहाँ पर rings different है, so I can shift the pi electron from left to right or right to left, getting two different compounds. अब if I shift from left to right, is this one stable? Quick, quick, quick.
No.
No, because it is anti-aromatic. But अगर मैं reverse करूँ तो यहाँ plus और यहाँ minus. Is the first one stable now?
Yes.
Yes, because it is aromatic, and then the next one is also aromatic. मतलब यहाँ पर if the pi electron is shifted from right to left, which can happen on its own because it is acquiring extra stability due to aromatic character of both the rings. So it is a spontaneous thing. मतलब the pi electron will be shifting on its own because the two rings are becoming highly stable. So the molecule will consume its own energy, shift the pi electron, and lower the energy of the system and gain more stability. And based on this, the double will change to single and the free rotation will be allowed. Option B is correct. अब एक बार ये फंडा क्लियर हो गया तो कोई भी टाइप का क्वेश्चन कर सकते हो आप. तो नेक्स्ट में what will be the polarities? I have a 7-membered ring with the double bonds here and a 5-membered ring.
Plus on the left and minus on the right.
Plus on the left gives me tropylium ion and minus on the right gives me cyclopentadienyl anion, and that is definitely aromatic due to Huckel's rule. मतलब यहाँ पर भी shifting होगा possible, molecule will convert to a double bond, sorry, from double to single, and the rotation would be possible. And option D में I have a 5-membered ring and a 5-membered ring. अब दोनों rings अगर similar है तो फिर problem है, right ना? Because here if I shift from plus left to right or right to left doesn't matter, but if I have the polarities like this, the first one becomes anti-aromatic and the shifting of the pi electron won't be allowed. Okay, so the correct answer here is B and C. Very, very good question. If you remember, then okay, then match the column type का एक question ले लेते हैं 34th. So simply you have to match it with the type of the isomerism. First one, what can you say as a statement? Just by looking at the compound quickly. क्या बोलोगे?
Why?
It's cumulene with even number of double bond which show OI. So this will match with Q. Second one is the amine and it's a secondary amine. So it can show
Metamer.
metamer. Because metamerism के लिए there should be a polyvalent functional group with the number of carbons on either side different. Then we have the famous unsaturated dicarboxylic acid, which can show
P.
P, geometric isomerism. And if this is cis, what was the name?
Malic.
Malic. And trans was named as
Fumaric.
Fumaric. And the last one, just by looking at the compound, क्या बोलोगे? What do you observe?
Tautomerism.
Tautomerism, but what is special about this compound? It's a beta dicarbonyl compound where this particular CH2 group becomes an active methylene group, and this particular compound can gain extra stability in the enol form due to intramolecular H bonding and resonance.
So why can't D show metamerism?
Which one?
D.
B,
B.
D, this one, carbonyl compound.
So
How this will show a cyclic compound? कैसे बताएगा?
okay, sir.
Cyclic will not be able to show metamerism. If I have the open chain with one carbonyl group and I have, let's say, one methyl over here and propyl over here, then this will be a metamer of a ketonic compound with both sides ethyl group. These two are metamers. So monocarbonyl compounds may, if the number of carbons on either sides are different, then they are a pair of metamers. साइक्लिक में नहीं होगा. Right?
Yes, sir.
35, integer type. The compound X has a molecular formula C4H7Cl. Find out the number of its cyclic isomers, structural and geometrical, only excluding optical. Now it is clearly mentioned we have to find cyclic, maybe structural and geometrical, and not the optical. So what is the first thing you will start with?
Du1.
Du, and that comes out to be equal to 1. Fine. And then cyclic में 4 carbon. What is the first structure you can think?
Cyclopropene.
ठीक है. Cyclopropane. Then
Cyclobutane.
cyclobutane. Perfect. So 4 carbon है. It can either have a cyclic ring of 4 carbon or a cyclic ring of 3 carbon. Perfectly okay. अब जो cyclopropane है उसमें chlorine and 1 carbon, how will that arrange?
Together or adjacent.
Together or adjacent. मतलब I can have a chloro and a methyl on the same carbon, or the chloro and the methyl on the adjacent carbon. Any other possibility?
CH2Cl.
Yes, I can have a benzyl type of structure. मतलब one carbon and one chlorine, they can be together in the form of CH2Cl, together on the same carbon or on the adjacent carbon. ठीक है. And then cyclobutane अगर होगा तो I will have Cl only on one of the carbon. ठीक है. So these are my structural isomers. अब structural के साथ we have to also think about the geometrical. Will the first one show geometrical isomerism?
No.
No, two substituents on the same carbon will not show GI. Here,
Yes.
yes, इसका cis plus trans होगा तो इसके 2 गिनेंगे. Next one, नहीं होगा इसका कोई, and इसका भी नहीं होगा. Now the total isomers are 4 structural and 2 geometrical. मतलब with one common, the answer will be 5. This is how you have to find the isomers. First structural, then geometrical, and then fine.
Sir.
Understood this?
Yes, sir.
Next, now 39. This is a good question. Find out number of conformation those have cis geometry. Number of conformation that have a cis geometry. So I have a methyl over here and methyl over here. First of all, which are the positions on which the methyl groups are attached?
1,3.
1,3. 1,3 में, if I talk about this position and this position, they are axial methyl groups or equatorial?
Equatorial.
Equatorial. So I can say this is 1,3 equatorial equatorial disubstituted compound. ठीक है. अब 1,3 में cis वाला arrangement क्या होता है? Is it EE or AE? hopefully you remember this. See, let's say I have this as my cyclohexane. This is the first carbon, this is second, this is third, fourth, fifth, and sixth. So first carbon, if this is the equatorial position, second में down, third में up, fourth में down, fifth में up, and sixth में down. Okay. So if I consider 1 and 3, then the axial substituents are on the same side. So I can have a cis axial axial or cis equatorial equatorial. And the trans will be one axial and one equatorial. That's how we have discussed about cis and trans of 1,2 disubstituted cycloalkane, right? Yes or no?
Yes, sir.
And अब इसमें cis and trans में which was more stable? Wait, in a disubstituted cycloalkane, if the two substituents are on equatorial position, it is having the maximum stability. So cis equatorial equatorial was more stable as compared with trans. तो यहाँ पर
So, but
this
1,
arrangement,
3 had an exception, no?
the exception was cis is more stable than trans, and it does not have any optical isomerism possible. मैंने conclusion क्या दिया था? 1,2 में and 1,4 में trans is more stable, and the reason is simple. If you see 1 and 4 का substituent, ठीक है? So this axial and axial are on the opposite side, so it will be trans AA. जैसे ट्रांस ए होगा वैसे ट्रांस ई भी होगा एंड सिस वाला ए होगा. इस केस में द ट्रांस वन इज द मोर स्टेबल. और 1,2 में भी सेम फंडा अप्लाई होता है, राइट? मैंने क्या बोला था? 1,2 एंड 1,4 में एज पर द जनरल स्टेबिलिटी ऑर्डर ट्रांस इज मोर स्टेबल देन cis. But 1,3 के केस में the cis is more stable with the simple reason that the two substituents are on the equatorial position when it is the cis arrangement. And दूसरी बात, मैंने क्या बोला था? ऑप्टिकल के लिए एक सिंपल स्टेटमेंट याद रखना है. 1,2 का
Trans 1 4 is
बस shows,
OI.
मीनिंग 1,3 में दो चीजें डिफरेंट है. एक, cis is more stable than trans, and दूसरा, it does not show the OI in any of its conformation because of the symmetry. समझा? That was a simple summary which I had given. So, coming back to the question, this 1,3 disubstituted compound with equatorial equatorial is definitely a cis isomer. So, next structure अगर देखोगे तो it is 1,2 and it is what type? क्या बोलोगे उसको? Just look at the methyl. One is up and one is equatorial. So AE, right? Are you all getting it?
Yes, sir.
Hello. So now if it is AE and it is 1,2, is this a cis isomer? Yes. Simple है ना?
So I didn't understand.
Look at the next structure. The next structure is having the two methyl groups like this. One is given up and one is given on the side. What is this position called?
AE.
So that's what I've written. This is 1,2 and it is AE. Now 1,2 के केस में या 1,4 के केस में the AE is what isomer? Cis or trans?
Cis.
Have you understood? I'll explain you once again. This is the axial and this is the axial position. If the two axial positions are up and down, what type of isomer is that?
Trans.
Similarly, if AA is trans, even the EE of 1, 2 will be a
Just I got it now. I got it.
third structure. Now, can you tell me directly? It is 1, comma
4.
4 and it is
EE.
EE. So 1, 4 में EE is what type? Cis or trans?
Trans.
रेफरेंस आपको ऊपर दिया हुआ है ट्रांस. ठीक है, ये 1, 3 के लिए है. तो 1, 2, 1, 3 एंड 1, 4 आई हैव एक्सप्लेन्ड दिस इन डिटेल, बट उसका शॉर्ट समरी मैंने आपको बहुत सिंपल वे में दिया हुआ है. दैट इज व्हाट यू हैव टू रिमेंबर एंड अंडरस्टैंड. नेक्स्ट स्ट्रक्चर इज 1, कॉमा बोलो.
1,3.
Ananya, participate in the discussion. Purav, Kanish, 1, 3. What is the type?
AE.
AE. And 1, 3 में AE is
Trans.
trans. Next one is half chair में दिया है, but you can understand the position clearly. What is that?
1,3 EE.
1, 3. E नहीं होगा. It's vertical lines. Equatorial हमेशा इस तरह से होगा. Vertical line is always the axial.
AA.
It will be AA. अब E बोला तो भी फर्क नहीं पड़ेगा, because it will either be the trans or the isomer will be same. इसमें फर्क नहीं पड़ेगा. Still vertical lines are axial. Remember that. The 1, 3 में AA is what? This na.
Yes, sir.
Next one.
1,4 AA.
1, 4 AA is what type?
Trans.
Understood how to solve this question? Is this part clear?
Yes, sir.
So the question was, how many of these conformers have the cis geometry? And there are 3 of them. Answer will be 3. Now 40th question में the structures which are given are lesser as compared to what the answer is given. ठीक, आंसर 4 दिया है लेकिन 4 से स्ट्रक्चर ही नहीं है. Anyways, we'll solve the question based on what is given. 40th में the question is identify number of compounds that can show GI. So there is a cyclopentane double bond carbon with a methyl. Is this a geometrical center?
No.
No. The methyl groups are clashing. Next, you will read it as there are 3 double bonds. Okay. You will read it as a
Cumulene with 3 double bonds.
cumulene with 3, meaning odd number of double bonds will show.
GI.
तो ये GI बताएगा, ये नहीं बताएगा. And next is a cumulene with even number of double bonds, even shows OI. मतलब यहाँ पर ये GI नहीं बताएगा, but OI बता सकता है. ठीक है. Out of the 3 structures given, the answer will be 1. Answer जो उन्होंने दिया है, that's 4, which is not possible. I think some structures are missing. Then passage में about cyclohexane, cis, trans, everything is given, which we already know. Let's directly solve the questions. 41. Find out most stable substituted cyclohexane among the following. So the substituents are observed at what positions?
1,4.
1, 4. One is a methyl and other is a plus, which is a third butyl. What are the preferable positions for them to be more stable? Most stable होने के लिए the two substituents should lie on what position?
Equatorial.
बस simple है ना, मतलब the methyl and the third butyl both should be on the equatorial. Just remember the rule of stability in case of the cyclic conformations of cyclohexane specifically. In the chair conformation, the two substituents, if they are on the equatorial, it imparts maximum stability to the conformation. The two axial ones will have the steric repulsions, due to which the stability is decreased. 41 is simple, based on two equatorial substituents. 42 may be same question. If there is 1,2-dichloro, which is more stable, quick. क्यों इतना टाइम लग रहा है? हेलो, 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 कैन यू ऑल हियर मी? हेलो,
Yes, sir.
अरे बोलो ना फिर. 42 का तो आंसर सिंपल है ना, मोस्ट स्टेबल कॉन्फॉर्मर ऑफ 1,2-डाइक्लोरो साइक्लोहेक्सेन.
P.
The two substituents have to be on equatorial position. इतना तो simple बता दिया rule. The first option is axial axial. The C option is axial equatorial, and B is equatorial equatorial. Remember, EE is the most stable arrangement for the chair conformation of cyclohexane. Just by looking at the structure, you should be able to answer. 43rd. Most stable conformer of cis 3-fluorocyclohexanol. Now, if you have fluoro and OH, what is the funda?
H bonding.
Intramolecular H bonding. So, if they are in the two equatorial position, now in this case, will there be H bonding possible between them?
No.
नहीं होगा. तो इस केस में cis isomer के arrangement में, if they are on the axial position like this, then the intramolecular H bonding would be possible, which gives more stability to the isomer. और इसका जो गॉच कॉन्फॉर्मर है वो ज्यादा स्टेबल होता है as compared to the staggered conformation. That is also one thing to be remembered. तो ये तो वैसे भी cyclic arrangement है. So the cis arrangement with two axial position will give you the more stability. इसमें आपको axial axial नहीं देखना है, तो B option correct नहीं होगा, A will be correct. Here equatorial equatorial doesn't work. That was a clear exception which we have discussed. Understood.
Yes, sir.
So the entire session of today was dedicated to geometrical isomer. Okay, so I hope whatever doubts you had in the GI, they are cleared by now. Still, whatever remaining MCQs are there, please solve it and complete the 3 DPPs before the next session. If possible, you can start with the optical. It's a huge DPP which is there given for optical. 70 questions है, उसमें subjective निकाल दो तो around 60 questions है फिर भी. So to solve, you will have a better grip on the solving of the optical isomer questions. Few of the questions are difficult. Definitely, I'll discuss them in the next session. But then start solving it at least. And
So
last
for Tuesday,
DPP. Hmm.
So for Tuesday's test, then what is the syllabus?
I was supposed to include the entire isomerism. What we can do is I can take a session on Monday. Monday I have a meeting. Is Sunday possible for all of you to take one session?
Yes, sir.
Anyone having any problem Sunday?
So Sunday,
Sunday,
but
we have
full.
a lot of classes.